Okay, we're working on 21.0 study guide, and we are graphing quadratic functions. So the study guide looks like this, 21.0, and our first question says, find the coordinates of the vertex of these quadratic equations. So we're going to start with this one right here, and we have to find the coordinates of the vertex. So I'm going to rewrite the equation here, and the equation is y equals x squared plus 4x plus 4. This is a quadratic equation because its highest exponent is a 2, so I know when I graph it, it's going to be a parabola that might look like this, or it'll be a U or an inverted U. I know that this is in standard form because standard form looks like this. So I know that my A value is a 1, my B value is 4, and my C value is 4. So A equals 1, B equals 4, and C equals 4. So the first thing I'm going to find is my axis of symmetry, and the way I find that is using x equals negative b over 2a. So I'm just going to plug in these a, b, and c terms into this little formula here. Now here's how I like to plug this in. I'm going to make my fraction. Whatever b is, I'm going to put it in parentheses. So b is 4. I'm going to put it in parentheses, and then I have to make it negative, so I'm going to put a negative sign in front of it. In my denominator, I have 2 times a, so 2 times a is positive 1. So I do that. Now, this is really negative 1 times 4, so that's negative 4 over 2, and if you simplify that, you get negative 2. So this all boils down to x equals negative 2 is my axis of symmetry. The axis of symmetry is a line. It's a vertical line that touches the x-axis at negative 2, and it cuts your parabola exactly in half. Okay? Now we're not graphing this particular function, but we do need to find the coordinates of the vertex. So if x is negative 2, I know that my vertex is going to be somewhere on that line because the vertex is the point where my parabola changes direction. So what I'm going to do is take the x value of my axis of symmetry, which is negative 2, and I'm going to plug it into my equation. Y equals 1x squared plus 4x plus 4. So everywhere I see an x, I'm going to replace it with a negative 2. So I have y equals 1 times negative 2 squared plus 4 times negative 2 plus 4. I find it really helpful to write it out this way every time. If I try to shortcut this and do it in my head, that's when I start making mistakes. So just a suggestion. Plus, of course, I want to see your work. Right here, I have multiplication and an exponent. I have to do my exponents first. I'm going to raise negative 2 to the second power, which means negative 2 times negative 2, which is positive 4. Then I'm going to multiply it by 1. Positive 4 times negative 2 is negative 8, and bring down your positive 4. Now you have multiplication, subtraction, addition. You have to multiply first. So this is 4 minus 8 plus 4. So I'm going to combine my terms now. I notice that when I combine my positives, I have 8 positives and I have 8 negatives, and those are going to cancel each other out completely. So negative 2 and 0 are the coordinates of my vertex. So here I'm going to put -2, 0 as the coordinates of my vertex. Okay? We're going to do the same thing with y equals -2x squared plus 4x plus 2. This is my A, B, and C. Those are my values for A, B, and C. This is in standard form, ax squared plus bx plus c. So A is -2, B is 4, and C is 2. So to find my axis of symmetry, I'm going to use this cute little formula right here. So I'm going to plug in B is 4, so I'm going to put it in parentheses. But then whatever B is, I have to make it negative. So I'm going to do that. And 2 times A would be 2 times A is -2. So -1 times 4 is -4 over -4, and that equals 1 whole. So that's x equals 1 is my axis of symmetry. That's the equation for my axis of symmetry. That straight vertical line that cuts my parabola exactly in half. Now I want to find my vertex, so I'm going to take the x value, that's my axis of symmetry, and I'm going to plug it into my equation. Now again, this is really, really important. I have -2, and I'm going to multiply that times 1 squared plus 4 times 1 plus 2. I have to do my exponents before I multiply. So I'm going to square 1. 1 times 1 is 1. Then I'm going to multiply that by -2. 4 times 1 is 4 plus 2. -2 times 1 is -2 plus 4 plus 2. My +2 and my -2 cancel each other out, and I'm left with +4. So when x is 1 in this particular equation, y is 4. My vertex is the point 1, 4. These are the x and y coordinates of my vertex. So that's my answer for number 2, 1, 4. Okay. Now, let's look at number 3. Y equals x squared. And it asked me to find the axis of symmetry, asked me to find the vertex, and asked me to find the y-intercept. And then if needed, I need to find 1 or 2 more points. So I'm looking at this equation, y equals x squared. That's weird. Y equals x squared. I know that in standard form, a quadratic equation looks like this. So my x squared term is here, and its coefficient is 1. So A equals 1. I don't have a B term at all, so I'm going to have to assume that B is 0. And I don't have a C term, so I'm going to assume that C is 0 as well. The only term I have is my x squared term, and its coefficient is A, is 1. So there's my A, B, and C. So x equals -b over 2a is going to give me my axis of symmetry. So -b would be, b is 0. If I make it negative, that's kind of silly because b can't be, or 0 can't be negative anyway, but I'll write it down. And then 2 times a is 2 times 1. So I have 0 over 2, which equals 0. This is my axis of symmetry. So I'm going to graph x equals 0. Well, I notice that if I graph x equals 0, x is 0 right here, and the vertical line that touches that point is going to look like this. So that's my axis of symmetry. It's also my y-axis in this case. Sometimes that's true, sometimes it's not. So this is the axis of symmetry, x equals 0. Now it says find the vertex. So I'm going to take x equals 0 and I'm going to plug it in to the equation to find out what y is when x is 0. And my equation is y equals x squared. So if x is 0, y is going to be 0 squared. Well, that's just 0 times 0, which is 0. So 0, 0 are the coordinates of my vertex.